we're going to be talking about the Yocto Project and commercial aerospace. And if you had said that we would be having this conversation when I first got involved with this project, we probably would have laughed at you. But that was a long time ago. And the technology has changed a lot, and it's become a lot more repeatable, a lot better. The quality of the output is much higher. The paths that you can accidentally create failures has been reduced. There's just a story here over like 15 years of hard work by a lot of people to get to a build system for building embedded Linux images that people will now put in places that I never, ever in my entire life thought were possible. Yeah. And my name is Philip Balister, by the way, and I've been around for a long time. Tim has just introduced himself, if you've seen the last slide, so we can work off that. Yeah. And we'll go to Chuck, who is with the Boeing company and is basically the host of this panel.
Oh, really?
Well, you're the underlying motivation.
My name is Chuck. I'm an associate technical fellow at the Boeing company. I guess when I inherited an environment back in 2017, we were on Pyro. I pushed it to Thud as quickly as I could, and then over COVID pushed it to Hard Knot, and now we've got Kirkston builds. And I am told there is at least one one-off NAND build, and we are waiting for ScarthGap. We haven't even talked about ScarthGap yet. So we are not static by any stretch of the imagination. There is a lot of pressure being pushed from airplane programs who want it's the production mindset. They want stability. There's a lot of pressure to not change. But the other end, for anybody in aerospace may have heard of DO326 and DO356. I might get those wrong. That's the cybersecurity angle. 5 CVEs per day land that affect something somewhere in what we do per day. Now, our attack surface is tiny. It's actually practically zero. That actually is, in a lot of cases, zero. So these are not like RCEs or anything like that, but I advertise it as we are resetting the clock to zero when you go to a new LTS. Or in the case of Thud, it was the best we could do at the time, even though it wasn't an LTS. It's the best we could do at the time, but you're resetting the clock to zero. The trade-off is from Thud to Hard Knot, it was a big jump in Python, right? And unfortunately, in a tiny little place, we do have to have that variable in the builds, as I promised to, but the rest has been moved to Python 3. But that was a huge change.
Yeah, so when he's referencing I promised to switch to Python 3, right? So here's the problem, folks. Python 2 was end-of-lifed in 2018. It's got no support at all. None. Zero. None from upstream. Zero. Are there vulnerabilities in it? Yes, there are. So why are you still using it? Because, we have this huge code base. Okay. Was 10 years not enough planning time, et cetera, right? So this is the problem that, and that's just one component I'm picking on, right? So you can pick on any other component.
No, it's a good component. So that with things like Python 2, I don't know, I can't remember how long Python's been around, but Chuck and I talked at lunch, and he mentions that you may have a 35-year time frame for wanting to support a software build in the field. And how do you do that? Admittedly, their attack surface is very small, so you're really not worried about security vulnerabilities, but many times security vulnerabilities are also software bugs. And the question is, do you just fix that bug in case you end up with a path that goes through it that is not covered by your testing? Or you run the risk of fixing one bug and exposing another that then breaks your software.
Oh, yeah. And it's great that the Yocto project has repeatable builds. And unfortunately, if something occurs, and we hope it never does, A regulator could pin me down and say, I need you to repeat that build 20 years from now. Repeat the build.
That exact build.
Type, make, or bit bake and make that build occur, which means that's one of the reasons why we build our own virtual machine, which is a Yocto image recipe. And that virtual machine is the thing we run to do the nightly builds. Why? Because we can archive not only that virtual machine, but the recipe that created it. In fact, we found some weirdness reported back a long time ago. Still haven't resolved it, but some compiler issue when one compiler builds the next one, bootstrapping issue. That's why we ran into that. We have to have profound amount of commonality and archive that forever until the plane's not flying. So that's a huge burden in the rest of the world who says, well, we need to move on. And well, that's true between releases. You know, when the releases, we call it black label, it goes blue label, red label, black label. When it goes black label, that's done, and we can move on to a new Yocto release, even though we get a lot of pressure. It says, can't you do the next release with the old? No. 5 CVEs a day, folks. Okay.
Yeah. And so the thing is, when you've got a contract for a 30-year support, right? This is pretty common. I did a lot of military work. And so you have to escrow everything, right? So what does escrow mean? That means that everything, all the software, source code, right, is now backed up onto some media, and all the build system is backed up, and you know, even the hardware itself probably has to be mothballed, right? So now take all that stuff forward, right? Go back 30 years ago, think about what you had 30 years ago, right? So we're probably still talking about like magnetic tape media, or maybe you had some fancy new, you know, rewritable magneto-optical material, you know, matter, right? Well, those things themselves, that media that you're storing it on doesn't have a 30-year life. So that means you have to take it and copy it and back it up again, right? Well, that also means that you still have to have a zip drive, or, you know, all these old, you know, this old hardware to actually read the stuff and everything, right? So again, this virtual machine is absolutely one of the very, very strongly recommended approaches, right? Because you probably have a way of still running that somehow. But that virtual machine itself had to be stored somewhere. Where is that? Because that's got to be stored for, you know, 30 or 40 or 50 years.
And it's also why I'm not a huge fan of containers, okay? For my environment, for the stuff we do, because yes, the container mates to the surface of the kernel, and Linus Torvalds is really good about being militant about not breaking compatibility, but I don't buy it. In 30 years, I don't believe you. I do not believe you that container is still going to work on kernel 13, 15, whatever, wherever it is.
And so you have certain things like Kata containers where they do have a VM in the container, right? So maybe there are some ways there, right? But it's still fundamentally underneath it all. You've got a question, is C-group still working and so on?
Right. But you're now having a talk about some specific software implementations that are all the rage today. But you go back 35 years and you look at what you had then to do this, and you think, does anything 35 years old today that you used in computing, does it still work today? And you know, how you deliver digital data to your customers definitely evolved with time. And we're sort of digressing here into, you know, just one minor rat hole of delivering, you know, commercial software for aerospace and the life cycle involved. But what other problems do you see? I know at lunch we talked about, you know, you have some unique problems, but what problems, you know, do you face that you believe other people building embedded Linux distributions face? Yeah,
just so we're clear, the motive here is not to get what I want, is to find the intersection where we're the most productive. And I think a lot of the things that aerospace does lead what the rest of the industry might consider doing. If you understand, or if you study safety engineering, you know, it's hazard identification, design, mitigation, mitigate the hazards you discover in your hazards, and then implementation assurance. That's really just requirements, implementation, testing. That's just that by a different name. And so we're not doing anything radically different than the rest of the world. We just have to be a lot more formal about it, because 50,000 systems have to operate together with a simplistic interface on the flight deck. So we don't get to tell you, the SRE, to go out and fix a stack trace. So it does have to be boiled down. And so what we found so far is the Yocto project is really good on what we call low criticality. So we do it from A to E, A being the highest criticality, E being the lowest criticality. And there's an inversion as far as features go. The Yocto project's really useful for D and E criticality, but we want to get into C, B, and A. And so and so you can't, when you get into there, you got to specify the requirements down to the level that you could practically implement the code from there. Well, yeah, that does apply to the Linux kernel too. And so for all practical purposes, you have to be able to shave off and remove a lot of code. But we're not dumb. We want to be able to migrate forward to the next kernel version, to the next Yocto release, without having to redo all that work.
Yep. So if you've ever ridden a train in Austria, you have ridden in something that is running on safety critical Linux, because the train system in Austria runs on safety critical Linux, right? However, this was done a very long time ago. And what was the process? Analyze every line of code. So this is the thing that has to change, right? Because on top of that, you also have to have hardware which is predictable, and modern CPUs with multiple cores and different, hybrid cores and so on. Things are changing. So you can't go back and, have the 6502 instruction set memorized and everything that's going on. That's not the same anymore. So these are the challenges we have.
Yeah, and I feel like there is some level of convenience to anybody working on an embedded project. If we were to say the aerospace industry has really led the way to creating not just minimal, as in your image recipes, small, but we've actually pioneered ways to reduce the size of the amount of code. Suddenly your embedded device is going to be a lot sportier in that case. That's an example of what I'm saying is it's not just a unique problem that aerospace has. I think everybody can benefit from it, to be able to not only say, I'm going to carve out a whole bunch of, maybe you're not even using Python, you're at that level, but you're carving out a whole bunch of the kernel. I think a lot of other embedded environments would like that too.
So I was thinking that you mentioned safety, and there's the ELISA project. And I know that we talk back and forth a little bit about that, but that seems like a project that's going to attract people from outside of aerospace as well. So what other industries, do you know of that might be interested in this sort of work?
Well, I participate in the Aerospace Working Group, ELISA Aerospace Working Group. Steve Vanderleest runs it. He's also a Boeing engineer. He's a tech fellow. Obviously medical, obviously automotive. There is an automotive working group in ELISA. I feel like it's a real, using the Yocto project code to build proofs of concepts, particularly it's what you do in those working groups, is a really good way of sort of conveying the same language. It turns out, the aerospace working group can now use the same language that the automotive working group is using, because we're using a common set of tools in that case.
Yeah, and you've got transportation, you've got all kinds of civil infrastructure stuff, including power grid, nuclear reactors, all those kind of things.
Okay, that makes me happy and nervous all at the same time.
It's coming. I mean, there's probably trillions of dollars worth of not intellectual property, but intellectual effort in open source. It's just, there's not an economically feasible way to do that in a closed environment anymore. So it's just, that ship has long sailed.
Yeah, I mean, from my point of view, it's something I've grown a lot more comfortable with over time. I know 10 or so years ago, someone had a talk at FOSDEM on how they were using OpenEmbedded to build software for their medical device, which fortunately wasn't, life critical at the time. But, he was talking about a lot of these issues, how they were using, the process to help them with certify, and they could show their regulator what had changed. They didn't talk so much about the testing. But
no, I view this a lot as like the way automotive companies get into racing. Racing improves the breed. you actually see a lot of those innovations appear in the next model, and down the line in the same model years. I see the same thing with safety critical environments. We need to view this down to just the lines of code, and it comes into conflict because we need to do things a little differently. We don't just get to deploy, push on green, and then scurry around when, there's something in the log and say, oh, I need to fix that. We don't get that luxury. We have to craft it as a package, ship it out, and know that it works.
Yeah, and I really like that the racing analogy is the harder projects that people work on, we learn from them, and we learn where we need to drive the underlying technology so that they can focus on, their business logic and the important parts of the application. In this case, keeping the plane in the sky at, the ultimate case. But what it does is improve things for all users. I'll mention, back in the good old days, we had one sysroot for all recipes. And that would lead to some very interesting build failures because order of execution mattered, and that was horrible. And there were some very funny tests to trap those cases. But most people didn't care. But we went ahead and did recipe-specific sysroots, and it improved things for all users and made things a lot, much more predictable for a few.
And that's the goal here. The other part is, it may stun everybody. I know everybody's stunned to hear this, but not every Boeing software engineer who contributes to something that flies away in an embedded OS cares about Yocto OpenEmbedded, right? I know that's crazy to think about.
Crazy talk.
I know it's crazy talk, but that's not a reasonable expectation. No. If I can't say to a day one developer, clone repo, install the Visual Code plugin, run script, I have failed at my job.
Yeah.
And I gave a presentation last year at Open Source Summit North America, basically on that topic of how we've managed to achieve that. Clone repo, run script. And then if you want to know what we did, it's in there in the scripts.
Yeah.
Just type BB, bitbake, and you're off you go.
And I think, this is kind of like, this is the modern world we live in. One of the challenges we have, though, is with the agencies that are doing certifications, right? Because they move pretty slowly, right? And these regulations and the, the actual, DO, whatever.
DO 178.
178, right? That was written when and how many revisions has it been through and so on, right? So there's other ones for automotive and for safety critical and so on. There's all kinds of different standards. So one of the problems is that those standards themselves move very, very slowly. And yet we've got 5, CVEs a day, right? And so we somehow need to get these communities of these more slowly moving things out of deep conservatism in the classic sense, meaning they just want to make sure that they're checking everything and being very, very careful, right? But if it takes you 2 years to get certified, how many CVEs have been added to the product that you have before it ever got released, and so on, right? If it takes you that long, then you've already burned half of ScarthGap's life, right? So you're now gonna have a 30-year window on something that was 2 years into the 4 years.
And that's one of the reasons why our surface has to be just is zero, basically. It has to be so small because in that amount of time, you're guaranteed to have some pretty bad exploits appear. So we just simply cannot, there's a lot of features we can't do.
So one question I had, so you talked about getting people started in development. Mm-hmm. How does the VS Code work? Stuff. If you looked at that, is that going to be a big help?
We haven't even touched it yet.
Okay.
This is just now come onto our radar. So we haven't even touched it. Prior to this, it was all terminal, clone repo, and then use Vagrant to deploy from Vagrant file, then run the command. And it's all orchestrated for you. Everything's done for you. So the hardest part was like generating your SSH keys and getting them in GitLab, the whole 9 yards. So, but that was a lot of the work I did is put all that in and get it. So now any developer can do it, and it's gone a lot further since then.
Yeah.
So,
And I think this is one of the things. So there's some folks out there who seem to almost say like Yocto Project is already good enough and it's done, right? Like we don't need anything else, right? Well, look at what we're just talking about, right? This VS Code stuff's brand new, basically, right? I mean, it's been a couple of years or so in the works, but we've got a lot more ideas. And some of us would really like to be working on these other ideas, but we've got to do other things in between, right? And we have to live our lives. But I think that to say that there's no need for change and there's no way that Yocto Project could change to improve safety critical is absolute a fallacy, right? There's no way that that's the truth, right? So we could absolutely be improving things.
Yeah, and I don't want to disrupt anybody's existing workflow or anything like that. I don't think that's necessary here.
Yeah. I mean, what I'll say here is a few years ago, we went through a planning process to develop a 5-year plan. And a lot of the 5-year planning process, we had to close our eyes to how any of this work would get executed because everyone's running at full bandwidth and we have to bring in resources to execute. And then, a miracle occurred and the Sovereign Tech Fund appeared and asked us if we had money, and we had a plan to present to them that enabled us to turn the spigot on fairly quickly. As far as getting that work done.
And people actually applied and people actually did the work.
But I mean, a lot of that was we were prepared with ideas to feed. So my question for you is, I'm guessing that we're going to have to look at the 5-year plan because a lot of it is going to be done. What should we look at in the next 5 years?
Well, since Boeing is now a platinum member of the Yocto Project.
Thank you very much.
Beyond excited about that. We've been pushing on that rope for a long time. We finally got it.
Finally froze.
Yeah, we finally got it. I'd like to be part of that conversation.
Yeah.
I'd like to be part of that conversation.
And so if you're wondering why Philip and I are up on stage, it's because we both have worked in this space, right? So that's the reason. And so even though we may not actually actively be doing that now, that doesn't mean we won't be back into it. Yeah. And so I think that this is a call to action out there, just for those of you that are interested in safety critical or just extremely long-term support on mission critical hardware or mission critical software. Let's start those conversations and let's move forward because we know there are ways to do this. I think too many of them are still pretty siloed.
Yes.
It's getting better. Elisa and Siltulin XMP helped, but we need to get more of it in the open because everybody's got the same fundamental problem and the fundamental solutions are probably also common, right? Yes, you will always have your own specific problems that need to be done individually, but we should not all be trying to figure out how to get the Linux kernel certified to a safety standard. That should be something that's done at a foundation level, right? And then the other specific stuff happens later.
And it should improve the breed. It really should improve the entire breed. What comes out?
Yeah, I mean, the overlap I hear, we, as a project, 4-year support is pretty hard for us to do. And if people say they want longer support, I will refer you to, members of the Yocto Project who will provide that as a service. I mean, it gets expensive. Safety critical, we want to make it easy for people doing safety critical stuff to deliver safety critical stuff. This is, sort of a core project where we're looking for overlap amongst all the members to see where to put, project money to improve things. So if you have interests in long-term support, maybe not so much just extending the support, but making the tools and technology better to support it, better handling of smaller footprint systems, so you don't have to certify as much code. It's just a lot of reasons why this specific topic is very, very important for probably most of the people in this room.
So if we could start now, right, planning for the next LTS, which is 2 years from now, right? Now is enough runway that we could actually start making some things happen. So that might be, there's a new version of Pocky Tiny, which is Pocky Tiny with a nod towards, safety, right? We're not saying it's safety certified. We're saying it was developed with a eye towards the requirements for
Right.
safety certification. And then that starts the ball rolling. And so if we have that conversation, we start transitioning us to that frame of mind now, then in 2 years, when we're ready for the next LTS, we're even better off.
Yeah, the whole ecosystem will develop tools out of those needs and so on and so forth. It just keeps on growing in itself.
Okay, that pretty much runs us out of time. And unfortunately, I did not think of taking questions from the audience and ran us out of time.
And I talked a lot. Guess
I'm
what?
going to use this opportunity to promote the BOF that Megan had a slide on. And we're always looking for interaction at the BOF because that makes it more fun so we can carry on this conversation there.